Hi YouTube. We are ready for Untitled Code day 10. So let's start. Adapter array. Page into the aircraft's data port, you discover weather forecasts of a massive tropical storm. Before you can figure out whether it will impact your vacation plans, however, your device suddenly turns off. Oh yeah, sorry. I should fix this. I forgot. Thank you. Okay. So you'll need to plug it in. There is only one problem. The charging outlet near your seat produces the wrong number of jolts. Always prepare, you make a list of all the Joltage adapters in your bag. Each of your Joltage adapter is rated for a specific output Joltage, your puzzle input. And the given adapter can take in input 1, 2, or 3 jolts lower than its rating and still produce the rated output Joltage. In addition, your device has a built-in Joltage adapter rated for 3 jolts higher. This is worrying. Oh god, this is like a search. And depending on the size of the input might be too big to like be naive, but we'll see. In addition, your device has a built-in adapters, 3 jolts higher than the highest rated adapter in your bag. If your adapter list were 3, 9, and 6, your device built-in adapter would be rated for 12 jolts. Right, 3 more 9. 3. The charging outlet near your seat as having an effective joltage rating of 0. Since you have some time to kill, you might as well test all your adapters. You wouldn't want to get to your resort and realize you can't even charge your device. If you use every adapter in your bag at once, what is the distribution of joltage differences between the charging outlet, the adapters, and your device? For example, suppose that in your bag you have adapters with the following joltage ratings. With these adapters, your device's built-in joltage adapter would be rated for 19, which is the highest, plus 3, 22 jolts, 3 higher than the highest rated adapter. Because adapters can only connect to a source 1 to 3 jolts lower than its rating, in order to use every adapter, you would need to choose them like this. The charging outlet has an effective rating of 0 jolts, so the only adapter that could connect to it directly will need to have a joltage rating of 1, 2, or 3 jolts. If of these, only one you have is an adapter rated 1 jolt, right? From your 1 jolt rated adapter, the only choice is your 4 jolt rated adapter because it has a difference of 3. From 4 you can go blah 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 blah. After 12, your adapter rating is 15, then 16, then 19. Finally, your device's built-in adapter is always 3 higher than the highest adapter, so its rating is 22 jolts, always a difference of 3. In this example, when using every adapter, there are 7 differences of 1 jolt and 5 differences of 3 jolt. Here's a larger example. In this example, in a chain that uses all of the adapters, there are 22 differences of 1 jolt and 10 differences of 3 jolts. Find a chain that uses all of your adapters to connect the charging outlet to your device's built-in adapter and count the joltage difference between the charging outlet, the adapters, and your device. What is the number of 1 jolt differences multiplied by the number of 3 jolt differences? Whoa. Yeah, it's long and annoying. So we need to find a chain that uses all of them and then count how many differences, how many times we have a different, we go up by 1 and how many times we go up by 3. Now, also it says that we need to use all the adapters. So we have to hope that the list actually has that property. I mean, we can assume that it has, but weird prompt. Well, I guess this is the easy part, so it's... Can I just sort them and like... Why can't I sort them. Let me think about it. They always have to be higher, right? You always have to be... Any given adapter can take in an input of 1, 2, 3 jolts lower than its rating and still produce its rated output joltage. So like you only go up. So you sort the list and then you count how many 1 differences there are, how many 3 differences there are. So in this thing there are 22 differences. Oh, sometimes it's 0 maybe. Like let's just do the beginning here. We start with 1, then we go to 2, 1 difference, then we go to 3, again 1 difference, then we go to 4. Then there is no 5, I think. So we are searching for 7. Okay, 7, 8, 9, 10, 11, blah, 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 blah. So 22 differences of 1 jolt, 10 differences of 3 jolts. Like, it seems overcomplicated for what ends up being a simple thing that you need to search for. It is weird. I hope I'm not misunderstanding stuff. Don't save. We are doing... Save this header. We are doing day 10. We need input. Joltages. .txt, I guess. Oh, I had this already open. Anyway, I have joltages, const data equals import. Oh, where's my LSP at? Restart servers. It's not import, it's embed file. Why is my LSP stuff not suggesting anything? Weird. So new keyboard Loris. No, new mic. You can see it here. This mic captures the keyboard, and I'm not using Topre because you can only use Topre with a Topre keyboard. This one is like assembled by me. Well, not entirely, partially assembled by me, I guess. Anyway, so we have the data, we have the joltages. I guess we read them in a list, we sort them, and then it's probably, I'm gonna mess it up. I don't know. It's probably deceptively easy. So var it equals std dot mem dot token. Why am I getting the annoyances at the bottom but not the suggestions at the top? Like I'm getting the worst of it. This is not fair. Let me restart supply. Also should enable the thing where it remembers the size of the window. Oh, thank you. Tokenize data, delimiter bytes, just new line. Well, how many joltages we have? Like, let's make it easy. 97. So var adapters. What did they say? 97, right? 97. Okay, 97. Use sizes. Oops. Size undefined. Yeah. What for each adapter thing? Want a pointer to an adapter, and actually can do this directly. Pointer to an adapter, and we set it to try std fmt parse not parse float. int usize it.next assert that it's there, base 10, and we're done. Then we have all the adapters. We sort it. Do we have any sorting stuff in the standard library? std sort, of course. Okay. Sort type usize items. Also uzzi. What was I saying? Yeah, adapters. Okay, items, adapters. Context. I don't know. Empty. Less than. Isn't there like a already std sort numbers easy? I mean, binary search insertion sort is sorted. Max min sort std size. No, okay. Okay, less than is, I don't know, function a usize, b usize. I forget already which side was. A greater, return a greater than b. Oh, don't tell me I can't even do this, right? Can I? Oh, I can do sort. Oh, thank God. std.sort.ask. Oh, on usize. Nice. Okay, that makes much more sense. So next, I'm assuming, is this an in place sort or is this returning stuff? std.sort. Is this returning something? I can't read if it's returning something from that for a thing. Let's see if Lord figures out the compiler error. Okay. Can somebody tell me if this is in place? It's in place. Okay, thank you. Okay, so this needs to be a slice. Next is gonna be so we sort them, and then we var count once size 0 count threes. And then var current. Nice. Size equals 0. And then what we do? For. Is this a ask? Okay, yeah, that's what we need. Yes, for each adapter. What do we do? I think we want to switch over the adapter minus the current, and then if it's 1, right? Because our needs to be higher, yes. So if it's 1, we do count ones plus equals 1. It's 3, we do count threes plus equals 1. If it's something else, we panic. Maybe we should print. Oh, you know what? Let's panic in a dumb way for now, and maybe improve this later if we do hit that case. We might not even encounter it. And then at the end, we always do current plus equals A. Okay, so this seems fairly easy. After we have run through every adapter, at the end we say print ones, threes, and result is going to be count ones, count threes times ones. Is this really it? The text also had my current device. Is my current device like, do we need to factor it in? Find the chain that uses all your adapters to connect the charging outlet to your device built-in adapter and count the joltage difference between the charging outlet, the adapters, and your device. So in this example, when using every adapter, there are 7 differences of 1, 5 differences of 3 joules. Here's a larger example. Okay, yeah, finally your device built-in adapter is always 3 higher than the highest adapter. Okay, so at the end, we need to do a extra step here where we say add the well, factor in the adapter, I guess. No, the device. Factor in the device, which is always a 3. So I guess count 3's plus equals 1. And maybe for good measure, we should also print its rating. Maybe it's useful later. I hope so, because otherwise it's a big waste of time. So device joltage. Device joltage is what? It's adapters. Also here, this needs to be plural. Adapters. The last one. Adapters dot. Well, you know what? It's the 96th slot. I know that. And that's it. 96 plus 3. I think that's it. Hello, Christopher. How's it going? I'm doing the daily advent of code. It seems weirdly complicated, the explanation, and weirdly easy. Oops, wrong window. Sorry. And weirdly easy the algorithm. I'm a bit spooked, honestly. I think I'm missing something. We'll see. Build day 10. Okay, expected type function, blah blah blah. Expected type function struct something your size found void your size. Okay. And this means needs to be void. Is this a type? Is the type of context then, not an instance? No, wait, if it was a type, I think we would have been told it's a type, not an any type. Runtime value cannot be passed to comp time arg. Oh no, sad face. Heck. So somewhere there is a difference that is not 3 nor 2. Let's inspect what's going on here. I mean, maybe it's fine. Maybe 2s are allowed. We just don't care about those. So std print weird difference. Let's capture it. So weird difference between and new line x. Then what do we want? We want, let's say, current and the current adapter, I guess, that we are picking up. Let's see. And that's it. And then we continue. Okay, weird difference 2 between 3 and 5. Weird difference 0 between 8 and 8. Wait a second. Wait, what? These numbers never go negative, do they? They don't go negative. What is this thing talking about? You know, I should sort these lines in Sublime, by the way. I should really sort these lines in Sublime. Makes it easier. Would make it easier for me. Okay, weird difference 2 between 3 and 5. Let's check. So we have 5, yes. We have 3. We need to use all the adapters, right? So we have 1 here. Where the hell is 3? Excuse me? Oh yeah, but because 3 is the sum, it's not the previous adapter. So we have 1, we have 2, and then we have 5. Oh right, because the current doesn't need the sum. The current is the stage that we're at. We're not summing anything. Oh god, there we go, I found the problem. Yeah, current is the current, like it's actually the current adapter. Okay, so now we don't have this weird case anymore. Everything is correct. So device Joltage is 158. You have 68 ones, 33s. Did I increase it by 1 here? Yes. And the result is 2040. Let's see. Okay. Yeah, editor source, my favorite sorting algorithm. That error message is way better than it was 2 months ago. Yeah, I think so, but you know why I was able to understand this? Because I've done a bit of comp time. I would say that the error message is nowhere near good enough to explain to people that are not familiar with this stuff what to do. But I understood that if we here are passing a context thing, then this is probably expected to accept that type. But that type we are not. I'm not defining it because I'm inheriting it from the definition of this generic function here. And when it said struct something something, we should have said like tuple. I think we should really name things that are tuples, or like even consider empty structs tuples when in doubt. I think, and but the reason why I was able to make the connection is because this was any type. So I knew that this wasn't a type, this was an instance of something, and this was supposed to accept the type of this thing. So I don't know, I think it needs to be... I think there is a long way to get a comprehensible error message there. To completely determine whether you have enough adapters, you'll need to figure out how many different ways they can be arranged. Okay. Every arrangement needs to connect the charging outlet to your device. The previous rules about when adapters can successfully correct still apply. The first example above, the one that starts with 16, 10, and 15, so the shortest one, supports the following arrangements. Okay, so now we're starting to talk about possibilities. Okay, so this now it's a search. Charging outlet and your device's built-in adapter are shown in parentheses. Okay. Given the adapters from the first example, the total number of arrangements that connect the charging outlet to your device is 8. Okay. The second example above, the one that starts with 23 blah blah blah, has a bunch more. Okay, in total, this set of adapters can connect the charging outlet to your device in a big number of distinct arrangements. You glance back down at your bag and try to remember why you brought so many adapters. There must be more than 1 trillion valid ways to arrange them. Surely there must be an efficient way to count the arrangements. What is the total number of distinct ways you can arrange the adapters to connect the charging outlet to your device? This smells like dynamic programming. Oof. Oof, 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 oof. So, how do you tackle this problem? um, how do you tackle this problem? So the idea is, I would say the idea is, you can see here that to reach 4, there is only one combination. Then you can reach 5 in one combination, you can reach 6 in one combination, you can reach 7 in one combination. Sorry, that's wrong. You can reach 5 in one combination, you can reach 6 in two combinations, you can reach 7 in... Hey, Erose, thank you. Thank you for the raid. Welcome to everyone that's just joined. I had never heard of dynamic programming before. Well, I guess you missed out on something, but not much, honestly. So the idea is, I think you want to keep count of how many ways you have to reach a certain threshold of Joltage. And then, so for example, if you reach 6, there are, we just said that there are 2 ways of reaching 6, right? Then everything above that uses 6, you multiply it by 2 because you have 2 ways of reaching 6. And this is like a recursive structure because to reach 6, you have 2 possibilities. And then to reach, I don't know, 10, you will have a bunch of possibilities, some of which factor in 6, some don't. But you know that the ones that factor in 6, and here there are how many? 1 and 2. And you know that you need to multiply this by 2. It's 4 total because to reach 6, you can do it in 2 different ways. And here you see it all laid out to you because this is enumerating all possibilities. But clearly we don't have this. Like, we are trying to construct this. Actually, we are trying to even avoid constructing the full list. So thank you for the raid yesterday. No worries. You were doing something interesting. A compiler in C, right? Do I remember correctly? So, and that's how you build your solution up to the final Joltage. Now, it's been a while since I've done this stuff, so I'm gonna stumble in a bunch of different ways. I used to know how to do this first try, not anymore. It's been way too long. So, I don't know, let's do part 1, and then part 2. Return part 2. Well, the good news is that we did this, and we know what our device Joltage is. So we know what the target is. So const device is this. So we know the upper bound. Const outlet. I don't know if this is useful, but let's just write them both down. So we know the beginning, we know the beginning, we know the end. You can do it both ways. Like, you can go upwards or you can go downwards. I think nothing changes, whichever you choose. Although maybe going from the top to the bottom, the result ends up looking nicer. I'm not sure. Yeah, that's one getting pretty complex. Are these some programming challenges you're doing? Oh yes, it's I'm doing the advent of code. So you can, let me open it in another tab. You can check this out. It's you go to adventofcode.com and you can sign up, and it's every day. It's an advent calendar, right? So every day you get 2 programming challenges until the 25th, and the next one is going to unlock in 11 hours. And there are leaderboards, and you can solve these exercises with whatever programming language you want, because you're not supposed to, you don't submit the program, you just submit the result, and how you get to the result, it's up to you. Like technically you don't even need a computer, like if you like manual labor. And there's a global ranking, and we also have a private Zig leaderboard where all the people here are doing the exercises using Zig. Yeah, if you like pain. And it's fun. Until now, they weren't particularly hard. This one is a bit harder because it starts being about searches and optimization. I think it's where the computer science starts getting a bit harder. Although, I wonder if you could brute force this. I mean, it's not like, I don't know, maybe 97 is already too much, but it seems like one could maybe still brute force it. Worst case, you leave it running a couple of hours. Well, no, worst case. Worst case can be much worse than that. But probably 97 is in that range. I don't know, it's been a while. I remember being able to do pretty gnarly stuff with Python, so I'm assuming in Zig you can probably squish a bit more out of your computer. Okay, so... Wait, what? Specs guy second? You mean second in the global ranking? Oh shit, I didn't check. Leaderboard. No. Where's the Zig people here? Is there something that is gonna tell me? Oh yeah, in the Zig one. Okay, okay. Okay, so we need to do this thing. Do I remember about dynamic programming? Not really. I don't remember shit, but let's try to reinvent everything from scratch. So we were saying that we want to know for each Joltage how many ways you can get there. And this solution is going to depend on the solution on the Joltages before that. And you keep multiplying it going up. So I think that a starting point is an array of Joltages. So these are not adapters anymore. These are Joltages. And by the way, I still need the adapters too. So let's copy this stuff over. So we have the adapters. Now, Joltages. Joltages is an array of usize, but it contains 158 slots. I think 158 is enough. I'm thinking if I need to do a +1 thing. No, I don't. So actually, no, is undefined okay? I think it's undefined is okay. Let me think. No, it's not okay. I need to zero it, I think. So let's zero it. Okay, so we have our 0 Joltages. And then what do we do with these Joltages? So how many ways do you have to get to 0? And the answer is 1. Actually, you know what? Should this be? No, it should be 0. So, Joltages to get to 0. We know it's only one combination. How many combinations allow you to go to from 0 to 1? Now, we need to look in our bag and see. So now I think it's going to be 4. Or I'm wondering if I need to start from 1. I probably need to start from 1. So from Joltages, and I need a pointer to the Joltage because we're gonna write in there, and I need the index. Although, you know what? Let's not do pointer. Let's write to the index. I think it's gonna be clearer rather than reference and dereference stuff all over the place. So, Loya, if you want to see the solve, the stream recording is on my channel, second on the Zig leaderboard. Oh, okay. Match more Python is that slow in comparison to anything that is compiled. Oh yeah, sure. But the problem is these things get like exponentially complicated. Well, no, exponentially. Well, it depends on what you're doing. They tend to be like quadratic or worse as the number of as the input size increases, and like the range in which you go from instant to minutes to hours to millennia is not that big. Like you add 3 more elements and you switch from 1 day to 20 years. So you need to be careful. Like even if the programming language itself is much more efficient, it allows you to shift everything down by I don't know, 5-10 elements. Again, it depends on the algorithm, but like the like, how can I say, you can shift the window, but you cannot enlarge the window. Things that are gonna take millennia in Python are still gonna take millennia in Zig. You can't escape from that. So we have our joltages. The question now is, how do we? No, actually, now that I think about it, we never have to read from J. We only have to write. So, how many combinations are there to get to Joltage J? And the answer is it's gonna be a combination of what's before plus an adapter, right? So what we can do is we can follow the adapters, I think. I think we can do either. It doesn't matter which we decide to follow. So the idea is going to be for joltages that go from 0 until where we are now, not included, to get to our joltage is going to be oh, and I need to capture. How am I gonna call it? Let's call this J, and let's call this current. So all joltages, and I need the index because the index actually this is like combinations, and this is the J, which ends up being both the index and the joltage. So to get to joltage 1, it's gonna be joltage 0 plus a adapter that is compatible and that gets us to our current joltage. And actually, wait, this is gonna be combinations, and this is gonna be like let's call it C, and let's call this current. Hey, two-step, this one is tough. We'll see. I know the strategy. It's just a matter of implementing it. So joltage 0 needs to be combined with an adapter of the same size. At this point, here's what I'm thinking. Do I care about the adapters being sorted? I kinda do, because that tells me when I'm done. But at the same time, since I'm going one by one, the thing is, either I do have that adapter or I don't have that adapter. There are no other options. Like, it needs to be compatible, yes, but then it needs to bring me to this joltage. And since it's like A plus B equals C, A and C are fixed, so only B can only be one thing. So we don't even care about this sorting anymore. And I think we should change this to, you know what? To like a bit array that tells me whether the adapter, whether I have the adapter or I don't. Whether I have the adapter or I don't. Could I have problems where I'm trying to use an adapter multiple times? No, I don't. Because the adapters, I don't. It's impossible. No, I don't. So let's make this a bit array. adapters is a bool thing, and what I do is I try to parse the number. So now this is different. Now for it.next, sorry, while it.next, I get the Joltage, well, I get the line, and what I'm gonna do is parse the line. This is gonna give me a number, which is gonna be my index inside the adapters. And I set it to true. This clearly cannot stay undefined, because now this needs to be false when we don't touch it. Otherwise, we're gonna have big trouble. Okay, so this seems much more interesting. Let's put also the joltages here. Okay, so we have the joltages, we have the adapters on. We have whether we have the adapter or not. So the question is now in here, current adapter. Const needed adapter is current minus J. So do we have an adapter that allows me to go from J to the current joltage that I'm looking at? And the question then is, if we have in adapters the needed adapter, then for each way in which we got to for all the combinations that allowed us to go to the previous joltage, for each of those, let me think about it. So we have a bunch of ways to get there, and now we have one more. Do we just add one in our slot? Let me think about it. Maybe I'm doing something wrong. Okay, with the 0, 1 case, there was one way to get from 0, sorry, yeah, to get to joltage 0, there's 1, which is like the outlet. To go from 0 to 1, there is still gonna be one way. I think I'm missing something. No, I'm not missing anything, because this is right. So what we want to do is to increase by 1 the current adapter, current joltage that we are at. We want to add one combination, which is the current combination that we are doing. Okay. By the way, current is being like overloaded as a word. Sorry. We know that we have one more way of getting there. But what if we have one more way in this case, but what if we had 10 ways to go? What if you had 10 different outlets? So it means that now we had here, or if, yeah, this means that we would have 10 different ways to get to 1, because it's the same 0 to 1 adapter attached to each of the 10 different outlets. So we don't want to do 1. We want to do the previous combinations, the combinations that got us to the previous case. That sounds right. And these combinations keeps adding up. Do we add or do we multiply? No, we just add. Yes, I think add is the thing that allows us to combine everything. So this now, is this really just it? Is this really simple? So this brings us to, you know what? Also, why did I write this in main and not in part 2? So let's put this in part 2 where it's supposed to go. So now I guess, you know what I'm gonna do? I'm gonna print the result, which is gonna tell me how many possibilities there are to get to 158 at the end of the day. Hey, is this really it? Come on. Print for joltages. This is like combinations and jolts. Print JC. Is that it? Okay, let's see how part 2 runs. Also, programming errors, of course. Expected type size found bool. Where did I do this? Wait, what? Oh, sort. Oh yeah, sort, we don't sort anymore. Index out of bounds. Okay, interesting. Index out of bounds. Index out of bounds. These. Oh, is this J minus current? I think this is J minus current. It's the while loop. Oh, okay. Let me then undo the change that I just made. It's the while loop. Why? Let me see. Oh, I know why. Because the joltages, you're right. The joltages don't necessarily are in our range. Yes, some are outside of our range. So you know what? Let's do joltages that go from 0 until 159, so 158 included, and let the joltages are now a bit bigger so that we don't have problems anymore. Is this still out of bounds? Oh god, it's still out of bounds. Are there freakishly high joltages in here? No. Oh, okay, let me do a print then. Print done. I wish I had stack traces. I wish I stack traces. Term cap, hello. I wish I had stack traces. So yeah, we're still panicking in here. So this hack wasn't okay. Because I'm dumb, it's adapters that needs to be pumped up. So joltages is fine, but it's adapters that needs to be much bigger. And are we in here? No, we're just consulting existing things. Okay, so adapters, more adapters done, integer overflow. Okay. Interesting. So this is now okay. Yeah, because we have adapters that are much bigger. That's fine. And actually, you know what? It's easy. It's just a matter of seeing what the biggest adapter is, right? And we know it's 150 something, right? It's 3 less. Oops, it's 3 less than our thing. So this can just be 155th or 55, I guess. Although 1 goes in slot 1, 5 goes in slot 5. 155 goes in slot 155, which means that we need 156, I guess. Now we have integer overflow. Interesting that we have integer overflow. Oh, that's interesting. Is C star? Oh, I know why. No, I don't. Yes, I initialize to 0 all joltages, right? Okay, so there is never trash in here. Also, why did I say, okay, you know what we can do? Here what we can do, var, new combinations equals size equals 0, and we can do new combinations plus equals that, and only at the end we do c dot star equals new combinations. I mean, it's not, this shouldn't change the semantic of the thing, but it's a bit more clear that we don't care about what was in there. We are only scanning forward once, and so we are never reading from this, we're just writing into it. And that's why we can accumulate everything to new combinations. Now let me double check if what I'm doing makes sense, because there's clearly an error there if we are integer overflowing. Also, it would be interesting to know at what point we are integer overflowing. So joltages starting from, should I start from 0? No, why? Because I'm missing in the adapters. Or you know what? I could start from 0, and I don't need this hack here, because adapters are not writing to the line 0. So if I do adapters 0 equals 1, I can basically count the oh, you know what? Also, what I'm missing, I think I'm missing the device. So let's put the device also. Which means that this should be, oh sorry, adapters 0 equals true. Is this correct? Wait, okay. I'm getting confused by all this stuff. Let me undo some of these changes. Let's stay to where we were. Okay, let's think again about the beginning, because I'm probably messing around with the beginning or the end of the algorithm. So it starts at slot joltages 1, and it says current target, let's call it target J, target J is, to get to target J, we need to consult all joltages before target J. For each of these J, let's leave aside combinations for a moment. We need to know if target J minus J, so I want to get to 1 minus 0, which means 1, which means that I need an adapter of value 1 to get to the current joltage. Do we have an adapter of value 1? If so, we add how many combinations were there already. Oh, wait. There is an off by 1 error, I think, here. Target 0, sorry, 1 minus 0. This is 0. This is the value at index 0, which is 1. Yes, there was one way of getting there. And in our case, we do have the adapter, which means that we can add all the previous combinations to new combinations and then write it down. Target equals 0 on first iteration. By the way, let me double check. No, target doesn't equal 0 on first iteration because I start from 1. So target actually equals 1 on first iteration. Unless I'm missing something. Target is the eye into the slice. Oh god, am I doing this again? God fucking damn it. Thank you. You're right. I always do this. I'm such an idiot. I always do this. Thank you. I always do this every single time. This is my one weakness. This is my kryptonite. So you know what? I hate slicing. I need to make a rule. Never, unless you are 100% sure, never slices from the beginning and then try to grab the index because you're gonna do stupid shit. I mean, I could offset it by one by one every single time, but can we then at this point really fix this this stupid thing that I was doing by making this base case less special? So how do we make this base case less special? I don't think we can. I guess we can. I guess we can because we set this to 0. Oh, but new combinations is gonna change it. So you know what? If target J is 0, we continue. We have to special case it somehow. We still have our integer overflow though. That's nice. Then let's try to find out what else is going on. I guess I need to print some things. So print thank you for the blue screen, Lander. So target equals something. Thank you, Matt. No, but Kumari, I think you're right. That would mess up my algorithm anyway. How many bugs do you people have? I hope you're not gonna make me late for the meeting afterwards. So have the target. You know, the only good thing is that all these bags are gonna go back in the Federal Reserve. That's the only good thing. So as I was thinking, we have our target, and we need to know which Joltage we are considering now. Considering J combinations something. Present something else. New line. And now there's a bunch of things that we need to print. So target is target J. Considering, we are considering J, which has combinations, and is our adapter present? We see it here. Okay, so let's go print the bagging. Nice. Yeah, you're right. So let's put the print one line below, I guess. Okay, target 81, blah blah. Okay, so we're going up a lot. Target, blah blah blah. Considering 70. Is this generally correct? Just wait, what did the thing ask me? Sorry, I need to just double check what. In total set of adapters, you can have more than a trillion value ways. What is the total number of distinct ways you can arrange the adapters to connect charging outlet to your device? Is this generally, is this correct? But six? There are 15 ways to get to 6? Is it really possible there are 15 ways in my input to get to 6? What? No. I mean, 1, 2. What? To get to 6 there might be what? 3, 2, 3 maybe? Have 1, 2. Is there a 3? You don't even have a 3. So the 3 is not there, so we have to go to 5 from 2. Is there 4? There is no 4 either. Okay, you know what? Selection, edit, sort lines, thank you. Not exactly what I wanted. Is there like a numeric sort, please? Okay, whatever, better than nothing. So we do 1, 2, 5. I think the sum is wrong. We go to 5. And then, is there a 6? Wait, is there no 6 here? There isn't even a 6. Wait. That is a very important question. Do Italian people say opa? To say what? This is not an Italian word. I think. I don't know. Maybe it's an acronym that I don't know about, but like, no. Unless you're trying to... Is that like the phonetic pronunciation of a different word? So there is one way to go from 0 to 1. There is one way to go sorry, there is one way to get to 0 from nothingness. That's correct. We hard coded this. There is one way to go. By the way, this search could be really improved, I think. Oh wait, you know what? I'm such an idiot. We said that there are 2 conditions, right? One is, okay, so this thing is kind of wrong. So wait, is the adapter? No, there are the +3 -3. Oh my god, am I dumb? I think this formula here is completely wrong. You know why? Because I'm using like, I'm just saying, oh, the difference is 20. And then this thing scans everything and says, oh, do we have an adapter that has 20? And if yes, then it says yes, but that's wrong. That is indeed wrong. That is indeed wrong. Oh god. Okay. Like I right now I have I don't know. Let's say that the current target is 20, and then I'm considering 10, and the difference is 10. So this is telling me, do I have an adapter of value 10? But that's not what I want. I don't want an adapter to value 10. I want an adapter. I was building these completely in the wrong way. Okay. Now I'm realizing the error of my ways. I think we need more for loops, I guess. Wait a minute. No, we just need to check. We need to check. You need to relax. Let's imagine the situation. We are at Joltage 20 and we are considering a target of value 10. So the question is there a Joltage that will take us from value 10 to value 20? And the answer is no, 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 no. We can only find something that is 3 less our target Joltage, and then that brings us here. So the Joltages that we can consider are not going from 0 to whatever target J is. It's just going to be from 3 before to where we want to be, and then we have to find if any of these 3 adapters is available. The one that brings us 3 forward, the one that brings us... Oh, actually 2 is not even an option, so it's only 1. And that's it. Okay. This was such a dumb assumption. I forgot that there are 2 rules, and one is that the total sum needs to sum to our target thing, but then the second one is that we cannot combine everything together. We can only combine stuff that is 3 below us to where we want to be. So I guess we need to basically you want to do this. Whatever target Joltage we want to be at, we can only consider Joltages that are target J -3. So from -3 to target J, these are the Joltages that we can consider because these are the only ones that are compatible, which makes everything much more easy. The problem is when we start, target J -3 goes negative, which is kind of a problem. So we need to make basically this an expression. We need to save this somewhere and like cap it at 0. So const start is I don't know, SD math max between usize between 0 and this. Oh wait, can it be usize? Oh god. Okay, let's change this to if target -3 actually, oh yeah, target -3 is lower than 0, 0 else target -3. Nice, super inefficient. I like it. So that's our start. Let's say that we are at 3. It means that 3 means that 3 can be attached to the outlet. Our target Joltage is 3. So either we have a adapter of value 3 attached to the outlet. Yeah, okay, let's see. I think this might be enough, maybe. Let me think about it. Yeah, the linear adapter. This could be enough. Or not. Integer overflow again. But we are never printing. Really? Well, okay. Okay, let's see. I think the problem is this is gonna be from 0 to 1, which is an empty slice. Oh, by the way, this I think removes our special casing here. So it starts from 0 to 0, which is an empty slice, and then which means that it doesn't do anything. Oh, interesting. But this is gonna write down anyway. No, okay, let's not do this. So for each target, we start at target voltage 0. Our range is basically, oh, and we skip it. Then we do target voltage 1. And we say we can only, so to get to voltage target 1, you know, this is probably another thing that I need to initialize myself. So if voltage is minor than 1, it's minor than 2, I guess, or you know what, minor equals 1. So if voltage is target 1, we're done. If voltage is target 2, to get to voltage target 2, we can only do 0 to 2 not included. That's right. So from voltage 0 to get to 2, we're gonna need an adapter of 2. From voltage 1 to target 2. Oh, the needed adapter is the voltage itself. It's not the difference. Yeah, adapter of voltage J. Yes. Either we have 0, either we have 1. Okay, so this seems much better. Do I still have a needed adapter somewhere? Yes, J. Okay, integer overflow. Let me think about this condition here a bit more, just to be sure. We are saying we have target 2. So we start by looking at voltage 0. Voltage 0 has one possible combination. So, okay, no, this is still not correct. So from voltage 0 to our target voltage, we need target voltage. So we need an adapter of 2. From target 1 to voltage 2, from target 1 to voltage 2, oh, we need a 2. We always need target voltage. Why am I so dumb? Like, yeah, we always need the same, like, to get to voltage n, like this thing that these voltages have, like these adapters don't have a delta but have the final amount is has super thrown me off. We always need to, like, if I want to go to target 7, I always need to find an adapter of value 7. The question is, value 7 is compatible with 6, 5, and 4. So 7 can be combined with either of these things. And we just need to make sure we factor in all the previous combinations. Yeah, we always need to search for target J. Okay, integer overflow still. Also interesting, why are we not printing anymore? Like, we never get in here? What the hell? New line. Start target J. So let's see why we are not getting in there ever. Now this is kind of weird. Integer overflow. Oh, wait. Oh, wait. I start having integer overflows in here, I guess, when I reduce this. Okay, so whatever. Interesting. Is this really not enough? What do you want from me? Okay, that's kind of weird. Okay, so we're done with the while. Now, this is kind of crazy. How come? Oh, I'm overflowing. Don't tell me that I'm overflowing in this subtraction here. Okay, you know what? If target j is lower than 3. Oh god. Okay. So let's see. The numbers are still kind of crazy. Also, this is lying a little bit now, because so it's considering count present. So we are considering from. So the idea is we want to get to target 2. We are starting from 0. Do we have? Is this present? Do we have an adapter of value 2? We do. So this is correct. Then target is 2, considering 1. Oh, wait. We need to check only once. We need to check once if we have an adapter that brings us there. And then for each of these joltages, count the combinations once we are inside. We don't check inside anymore. So let's see. This makes more sense. Joltage 2, we're considering 0, present is true. Then we are considering, and let me change this to something different, to like print print target is this, and then just present. Yeah, target is present. Well, we know that it is present, so let's not reprint again. So this is from, and let's just count. Let's just count the combinations. So target is a then we want to print what we are considering now, how many combinations it has, and that's it. Okay, let's keep debugging. Okay, target 2. From 0, there is one combination. Then we want to get to 5. From 0, am I still doing the thing again? God damn it. God damn it. But I do want to only do these slices, so I need to offset j. I need to offset j, so we want to do well, let's call it idx, and we can say const j equals start plus idx. Okay, let's see if it makes sense now. So from target 2, from 0, yes, target 5, there are 2 ways from 2. That is indeed correct. Is it though? This is wrong again. This is wrong again. This is wrong again. Why? Because it's not true that these are two different combinations. Because actually, let me think about it. Can we go to 1? I think the answer is no. We cannot go to, or do we? Do we have an adapter that goes to 1? Oh yes, we do. Okay. So you can either plug the 2 directly, or you can plug the 1 and then the 2. So this is correct. There are 2 ways to get to current number 2. So from 2 to 5, we have an adapter. From 2 to 5, we have an adapter, which means that there are still 2 ways to go to 5. There is no adapter 3, there is no adapter 4. Can we confirm this? Yes, we are missing 3 and 4. Okay. Then the next target is going to be 6, for which we don't have any route to, or do we? Don't. There is no 6. There is no adapter of valued 6. Then we have, okay, I think I can trust target because it's such an easy check. Then 8. We have an adapter called 8. How do we get to 8? To 8, we can go from 5, which has 2 ways. But 6 and 7 have nothing, so whoops. So we cannot go from there. Okay. Then to 9, we have an adapter of value 9. And there are 2 ways to go there from 8. We have an adapter of 10. Why is 9 2 now? That is correct, because we can do 8 and then 10, or 8, then 9, and then 10. So this is correct. This looks kind of correct. Are we really overflowing? I mean, numbers are getting big. Is this really just overflowing use size? That seems weird. Also, wait. Oh, wait. Index out of bounds. Oh. I think we're actually doing fine. I think we got the answer. It's just that we were going out of, we have an index out of bounds because, I don't know, an off by 1 error. The question is, target is, well, though, wait. Target is 158. And the maximum value of the adapters is 156, right? 55. You know, I don't think I care. I think this is the number. These are all the ways you can get. So to 152, you don't get there. To 153, you don't get there. Assuming that everything is correct, this is how you get to 154. And then at the end, you attach your device and you're done. I think even though I'm getting an error, the algorithm is complete. That's the right answer. So, let's do some retrospective on how this went. It took me a while to actually what did I do? Oh, this is all part of the print. Okay. So it took me a while to actually get this algorithm right. I hard-coded, I think, a bit too much in the beginning. This stupid untyped numeric stuff was giving me underflow. Also, the thing, it says overflow, whether it is overflow or underflow. That doesn't help. Not having stuck traces, I'll be honest. That's fine. I think the problem is not having stuck traces does not help. I need stuck traces. That would have helped a lot. Anyway, it's fine. I chose this setup. So this threw me off for a while. It took me a while to understand the internal algorithm. So the strategy was easy. Like I can say that the time I spent in university was not completely wasted. I know that this was a dynamic programming problem. I know I can recognize that the structure is like it's recursive, right? The final solution is the solution of a smaller problem plus one extra step. And it's always the same step. And so you start from the base and then you crystallize the whole thing around it. So I knew also this. The problem is, it took me a while to internalize correctly the joltages that the adapters advertise, because for some reason for a while I was thinking of them as deltas, not as the final target. And then once this was solved, I think everything went well. I would say Zig did well. In this case, I think that like Zig wasn't really giving me anything particular. Like the other days with labels and stuff, I was like, it almost felt like cheating. This exercise was like dynamic programming is boring, honestly. You just need to look at the algorithm and make it work on the array. Well, I did get, you know what? I did get notified when I did underflow and stuff. Probably if this would see, I don't know, that would have been more annoying. But without proper stack traces, still I didn't have everything that I wanted. Anyway, in any case, could have been worse, I think. This was okay. So meeting in 5 minutes. That's just enough time to take a break and then show up there. So we're gonna have the stage 2 meeting in a moment. I don't know. I think I'm gonna call it a day here then. I hope that, well, is Firefox still here? Firefox, if you've never heard of dynamic programming, I hope this was probably not the best introduction, but at least something that gives you a general idea of how dynamic programming works and the type of class of problems that you can solve with it. And I don't know. Other than that, there's not much else to say. Actually, I'll say one thing. One thing that I didn't like about my university course is that they went to teaching us about dynamic programming, but I think it's worth, before going into dynamic programming, taking a look at memoization. I'm gonna write it. I'm not gonna send a message, but I'm gonna type it in here. Memoization. It's like you would expect an R to be there, right? Memorization, but there are no R's in this word. Memoization. And you can think of it as like a, I don't know, more freestyle version of doing what dynamic programming does. And honestly, I think the memoization is more useful than dynamic programming. I think professors in university would disagree. But what do they know? They don't do anything in real life. They only stay there in their ivory towers, in their university halls, preaching computer science and never getting anything done for real. So take a peek at what memoization does. And like, especially if you do Python, memoization in Python is so nice with function decorators. It is amazing. That said, when you are like, when you're going to war with problems, like when you have a big scale problem that you need to solve, and it has a dynamic programming, it has this crystalline structure that was defined, that I was mentioning earlier, you want to go for the full-fledged memoization approach where you systematically break it down, and because this is much more efficient than just random memoization. So I hope this was a useful introduction to these concepts for people who have never seen them. So without further ado, let's see if there's anybody that we can raid as we go into the meeting. Which, is anybody programming or is everybody playing Cyberpunk? Oh, okay, there are some people there. Anything interesting? Thank you, Ronaldo, for the follow. Let's see. Ooh, I could send you to the Visual Studio channel. I'm joking. I'll never. Let's see. Somebody that don't have. Oh, here I am. JavaScript bots. Anybody doing C stuff? Oh, there's somebody doing Advent of Code. Oh, I'll send you to another Advent of Coder so you can go take a peek at how other people are dealing with the problem. So enjoy and see you all tomorrow.